In this introductory tutorial, we'll build a fully parametric balustrade system using RailClone in 3ds Max. If this is your first time working with RailClone, the goal is to help you to understand how the plugin works, how it distributes geometry, how segments behave, and how to keep things modular, reusable, and editable. RailClone is available in two editions: the free light version, which includes a limited feature set, and the fully featured Pro version. Both can be used for this tutorial, and where there are differences between the two, we'll point them out during the relevant steps. Before we look at the RailClone setup, it's important to understand the components that make up a procedural style. At its core, RailClone is about combining geometry, which we call segments, along splines using a set of rules to generate a parametric object. Let's look at each of these in more detail. Segments are the mesh objects that RailClone distributes along a path. Each one is a piece of geometry from your 3D Studio Max scene. In this tutorial we use several segments: a balustrade, which is the main repeating section, a post which is placed at evenly spaced intervals and at the start and the end of the spline, and a street light which we can use for the same position, a lookout post which will be placed at the corners, and finally a bench which can be placed at specific locations using markers. To get started, we need to import these objects into a new RailClone graph by doing the following. First, you'd create a new RailClone object by clicking the toolbar button or using the command panel. Then drag a RailClone icon into the scene. Go to the Modify panel and open the Style rollout. Enable Use Segment Materials so that RailClone renders the material from the source geometry rather than the material applied directly to the RailClone object. And then click the button to open the node-based style editor. This editor is easy to understand. On the right hand side you have all the available nodes, and on the left you can view and edit the parameters of a selected node. And finally in the middle is where you construct your graph. To import multiple segments from the scene, the easiest way is to select them in the viewport. Then right click in the style editor and select Import Scene Selection. Note that light users do have a maximum of 3 segments they can import, so light users should choose the balustrade, the post and the bench to follow this tutorial. Next up, the path defines the route along which all the segments are arranged and deformed. In our example, the path follows the edge of the promenade. Let's import it into our graph. Add a new spline node to the RailClone graph. Go to the Properties panel and use the Object Picker button to select the spline from the scene. Collectively, we call segments, splines, and surfaces, though they're not used in this tutorial, base objects. And now that we have them in the graph, we can start creating the rules that govern how the geometry is assembled using a new type of node called a generator. Generators are the core of a RailClone style. They take a spline and they use it as a guide to distribute geometry based on a set of rules. In this scene, for example, we have a continuous balustrade punctured by posts and lights at regular intervals, with guardhouses on the corners. There are only 2 types of generators to learn, and for this tutorial we'll use the simplest one, the linear or L1S generator. Let's connect our segments and adjust the settings to see how it works. So add an L1S generator and then connect the balustrade segment to the default input and the spline to the spline input. This tells RailClone to repeat it continuously along the entire path. You can control how this default segment is distributed using the Rules tab in the generator's settings. In fact, if you're looking for layout options for any of the specific inputs, this is always the place to find them. At the top of the Rules tab, you'll find 4 default modes that control how the segment is placed along the path. Tile mode repeats the segments without scaling them, and when the segments reach a corner or the end of the path, they're simply sliced to fit. Adaptive mode automatically scales segments so they fill the spline exactly. This avoids slicing and it's more efficient because it allows the geometry to be instanced. Scale stretches a single segment to fill the spline section, and finally count fits a specified number of scaled segments along the spline section. For this example, adaptive is likely to be the best choice as it avoids partial balustrade elements and optimizes instancing. Next, add the post segment to the evenly input. This input distributes segments at regular intervals along the path, which is ideal for elements that appear at fixed points rather than continuously. Once connected, you can adjust the spacing and other properties from the generator's Rules tab. Mode controls how spacing is calculated. Choose distance and adjust the value to place a segment every set number of scene units. Or the other option is count, which defines a fixed number of evenly spaced segments along the spline section. We'll use distance in this example. Justify redistributes the segments along the splines so that the first and the last in each section are equally adjusted, with the rest spaced exactly using the distance value. This creates a symmetrical distribution that avoids the final section being larger or smaller than the start. And finally, adaptive mode. It's similar to Justify, except this option subtly adjusts the spacing of all of the segments slightly to maintain an even spacing. For most uses, I find this is the most suitable, unless the distance value has to be retained perfectly. You can experiment here. It's all fully parametric, so you can see updates instantly as you tweak the values. So to place a post at both ends of the spline, connect the segment to the start and end inputs of the generator. These inputs are used to add specific geometry once at the start and once at the end, but they don't have any specific rules in the Generators tab, so once you've wired them in, there's nothing more to do. If we look closely at the posts, you might notice that the balustrade doesn't perfectly align where they meet. And this often happens when the handrail or some other type of geometry has a specific shape or an offset that leaves a visible gap or an overlap. To fix that, we can use padding, a setting found in the segment properties rollout. Padding lets you adjust the spacing at the start and the end of a segment, effectively adjusting how it connects to the surrounding pieces. So to fix the alignment of this piece using padding, you'd select the post segment in the RailClone style editor, go to the properties panel on the left and look for the padding section. Decrease the start and the end padding values slightly. This causes the posts to slightly overlap with the balustrade, closing the gap caused by the shape of the moulding. Now, let's wire segments to the corners of the spline. So since RailClone Lite has a restriction on the number of segments, if you're a Lite user, you'll need to reuse the same post segment for the corner input. Pro users, on the other hand, can use a different segment for the corner input, in this case a kind of battlement or gatehouse. Once a segment is connected to the corner input, RailClone will attempt to deform it to follow the curve of the spline. To stop this, select the corner segment node. Go to the properties panel and open the deform section, and disable bend to stop the segment from curving around the corner. Remember, if there's a visible gap between the corner and the adjacent segments, you might also want to adjust the padding values on the segment to bring them closer together, just like we did with the posts earlier. Once the corner piece is connected and the segment configured, a few settings in the Generator's Rules tab can be edited to further control how the geometry behaves. For example, vertex type should be set to corner or Bezier corner. This tells RailClone which vertex types to consider as corners and place the attached geometry. Align to path should be enabled to make sure that the segment orientation bisects the angle of the corner. If this setting is disabled, the segment follows the direction of the preceding spline section. And finally, I'm going to set bevel mode to none. This prevents the default segments from continuing through to the corner, so only the corner segments appear here. The other modes allow the default segments to continue to the corner and give you options on how to slice those segments. So there's only one last input we haven't used yet, markers. This input allows you to place a segment at any position along the spline. To use it, apply a RailClone marker modifier to the spline. This modifier defines custom positions directly in the viewport by allowing you to click on the spline to add markers. It's ideal for placing things like benches, signs, lights, or any feature that needs manual positioning. So to add the benches using these markers, connect the bench segment to the marker input of the generator. Select the spline in your scene. Add the RailClone marker modifier, found in the modifiers list, and then in the modifier settings, click the Add Multiple Markers button and click on the spline where you want a bench to appear. If you want to edit the location of the bench, you can go to the Markers sub-object level and use Max's Select and Move tool to easily make adjustments. You can move, delete or reposition any markers at any time to fine-tune the layout. And that wraps up the different inputs you can assign geometry to in a linear generator. But we're not quite done yet. There are two more node types to explore: operators and parameters. Operators are a central part of the RailClone workflow. You can use them to group items, create patterns, randomize geometry, adjust UVs, process splines, and much more. In this section, we'll use one of the simplest and most commonly used nodes, the sequence operator. It's ideal when you want to create a repeating pattern, and in this example, we'll use it to alternate between posts and lights at regular intervals. To do this, drag a sequence operator between the post and the evenly input of the generator. and then wire the post and the light segments to the sequence node in the order you want them to appear. If you're using the light version, you could substitute the bench here instead of the light. This will create a repeating pattern along the spline, post light, and so on. So now that we've created a basic style using inputs and operators, let's make it more user-friendly. To do that, in this final section, we'll add parameters, a category of nodes that you control values directly from the Modify panel without needing to open the style editor. Parameters can be used to adjust numeric values, toggle geometry visibility, change materials, and much more. They're especially useful when you want to share a RailClone object with someone who doesn't need to edit the style itself. In this example, we'll add a numeric parameter to control the evenly spacing. So right-click on the generator and go to the Export Parameters menu. Navigate to the evenly and then evenly distance, tick it and click OK. This will add a new input to the generator. Now add a numeric node to the graph and wire it to the new input. Go to the properties and set the type to scene units and then give it a name, something like evenly spacing. Now if you come over to the Modify panel, and if you haven't got RailClone selected, click the red RailClone logo in the graph editor to reselect the RailClone object, and you'll see this new value is in the parameters rollout. And you can change it directly from the Max interface. In fact, you can close the graph now. You can also, of course, continue to edit the spline and move the markers. The whole thing can be updated as your project evolves. So in this tutorial, we've built a complete parametric balustrade using RailClone, from importing segments and defining layout rules to using operators for patterns and exposing parameters for easy control. If you want to go deeper, check out our other tutorials for more in-depth training and stay tuned for many new videos coming soon.